Yeah, let us see what was the question given here. F of x is what? E power of x square. We need to differentiate this function with the help of first principle or by the with the help of if they ask you definition, let us see how to do it. Okay. So now let us consider what is this given f of x. What is f of x here? This is e power x square. Is it okay? So what we already know, what is f dash of x? We know that f dash of x value will be what? Limit h tends to 0, f of x plus h minus f of x by h. So from this what we will do, what is f of x plus h? Wherever x is there, replace with x plus h in the given question. Is it okay? So this is nothing but simply e power, this is in place of x, I need to replace x plus h. For that you need to apply the whole square minus e power of x square by h. I think you understood, right? Now let us move on. So this is in the form of limit h tends to 0. Numerator, if you check it, okay, this is what a plus b whole square. What is the formula for a plus b whole square? A square plus b square plus 2ab. Is it okay? Minus plus every term will be as it is by h. So if you check it properly, if I take a limit h tends to 0, what I'll be getting? I'll be getting 0 by 0 by, which is 0 minus 0 by 0, which is indeterminate format. This is the not correct way of doing. So what I will suggest you is, whenever if you get this kind of a question, simply I'll suggest you try to take the e power of x square, e power of x or e power of x square, e power something common. Okay. So to make it e power of x square common, I think e power of x square is common in both, right? Yeah, you should know this. A power of m plus n. What is the formula? This is known as a power of m into a power of m, right? So if you check this properly, I can apply easily. I can rewrite this as limit h tends to 0, e power of x square. Agree. I will be taking common. I'll first time will be left with what? E power of h square plus 2hx minus 1 by h. Is it okay? So if you check it here, limit is over what? Limit is over h. So this term, that is e power of x square, does not contain any h value. Is it okay? So what should I do? I have to take it out from the limit. Is it okay? E power of x square. This is simply limit h tends to 0. Is it okay? And this will be e power of h square plus 2hx minus 1 by h. I think you got my point, right? So if you remember properly, we have a formula in the limits. What is the formula here? Limit x tends to 0, e power of x minus 1 by x will be what? Always 1. Whatever may be the power if you have, the same thing should be there in the denominator. This is the power. What is it? H square plus 2hx up, right? So now let us apply that one, right? What I should do that is not there in the denominator. Whenever if something is missing, try to add or subtract or try to multiply or divide. So in our case, I don't have an option like add or subtract. I have an option like multiply and divide. So what I will do, I don't change anything. I'll multiply here. Okay, h square equals 2hx and I'll divide h square plus 2hx by h. Is it okay? Why? Because if I cancel this 2, I'll be getting my question again, right? That is the way. Is it okay? So now let us continue. From this, what we can say, we can, if I take h tends to 0, this whole thing will be tending to 0. Agree? So I'll be simply, what? With the help of a formula, I can say that this is nothing but 1 unknown. This is nothing but limit h tends to 0. This is h square plus 2hx by h. So can I take h common from the numerator here? So simply take it out e power of x square. This is limit h tends to 0. If I take h common, I'll be getting h plus 2x by h. So what I can do, simply I'll cancel. From this I can say that e power of x square, what is this? I'll be left with limit h tends to 0, which is h plus 2x. Wherever h is there, try to replace its 0 value. E power of x square is equals to 0 plus 2x. It is always what? E power of x square into 2x. What is this? This is f dash of x. X is what? E power of x square. Its derivative. Okay. I think you got it. Right? If you have any doubts, just let me know. Thank you.